basic concept video. In this video we are going to say about hybridization. So what is hybridization? As even we are known to this general word hybrid in the sense we are having something an improved quantity. The quality is improved for our convenience. Okay, the hybridization of orbitals. For example, if I consider carbon, the electronic configuration of carbon is 1s2, 2s2 and 2p2. If I draw the orbital structures, 1s orbital contains 2 electrons and 2s orbital contains 2 electrons and 2p orbital contains 2 odd electrons. This 2p orbital. If suppose I consider the bond formed from 2s orbital and bond formed by 2p orbital. Why I am considering only this 2s and 2p orbital in this sense? Because this is the outermost orbit or valence orbit. So the valence orbital will involve itself inside the bond formation. So I will take this 2s orbital and 2p orbital. Suppose a bond is formed by this 2s orbital, then the bond will be purely sigma bond and it is non-directional in nature. Why? Because it is the s orbital. S orbital is spherical in nature. S orbital is spherical in nature. While I am considering the p orbital are dumbbell shape. I am just giving p orbital of px. So I am considering the x orbital alone. So it is dumbbell shape and the bond formed by the spherical orbital and the bond formed by the dumbbell orbital will not be same in its energy. But when I cleave the bond of methane, for example, I am taking this methane, I am having hydrogen, 4 hydrogen. So all the equal moieties are attached to carbon. This bond, just consider that it is projected from outside the board and this bond is projected inside the board and this is on the plane of the board. This 3-dimensionally, this bond is equally distributed. Why it is equally distributed? Because all the bonding orbital will have same energy. So here we consider this term called same energy. Same energy will lead the orbital to project equally in all directions. So I am considering this 2s orbital and 2p orbital. 2s orbital contains 2 electrons and 2p orbital contains px, py and pz. These are 2p orbitals and it contains 2 electrons here. So first we are hybridizing the sigma bonding orbital of p. This is pz. And py and py orbitals are considered to be pi bonding orbitals. And 2s orbital, when it is mixed with pz orbital. So 2s orbital with 2pz orbital will give you the number of orbitals taken in count will be equal to the number of hybrid orbital formed. The hybrid orbital is neither spherical. The hybrid orbital is non dumbbell shape, but the hybrid orbital will have a huge single lobe. This is s orbital and this is p orbital and this is sp orbital. Okay. And here we will get 2 sp orbital. So the hybridization of 2s orbital and 2pz orbital, that is sp hybridization. And if suppose I take one more orbital from here, so 2s orbital, 2px or 2py, px or py, whatever it may be, with pz. These are 2p orbitals and this will give 3 hybrid orbitals. Those orbitals are sp2. And if I am taking 2s orbital with the 2px orbital, the 2py orbital, plus 2pz orbital, It will give 4 hybrid orbitals, that is sp3 hybridized orbital. All the 4 hybrid orbital will have equal energy, will have equal bond length, will have equal distribution of electron. So everything will be equal in this hybrid orbital. So this hybrid orbital is constituted here in methane molecule. So all the 4 CH bond formula, all the 4 bonds are same in energy, and all the 4 bonds are equally distributed in 3-dimensional space, and all the 4 bonds are having the equal bond enthalpy also. So this is about the hybridization of carbon.